Welcome back, welcome back, welcome back. I'm Miss Lisa. This is my YouTube channel. Like, share, subscribe. What we're doing right now is this is physical science, and we are going to do a heat problem. So if you are taking the physical science class, it is in your book on page 162. And I like to do the math problems this way, where it's up close and you can see exactly what I'm doing and not on the board. I'd rather it be right up close. Okay, so in physical science, in physics, which is what we're doing, our problems are word problems. And the reason why people don't like word problems is they're confusing. But if we break them down, we can get rid of all the words and they're not confusing anymore. Because what makes word problems confusing is the words. Now, the kind of problem we're doing is a thermal energy one. And in your book, they have the formula as the heat is equal to the mass times the change in temperature times the specific heat. I like to write it this way. The symbol for heat is Q. Sometimes it's H in some of the physics books I've taught out of, but this one is using Q. And then times the mass times the specific heat times the change in the temperature. And the reason why I like it this way is because it says cat, and it's easier to remember. It's not really an A, it's the Greek letter delta, but it looks like cat. And you can think of that cats are nice, warm, little, furry creatures. So the formula for heat is cat. All right, so let's do the problem now. It says a wooden block has a mass of 20 kilograms. So we don't really care about anything until we get to a number. And it says that, now it might be important that it's wooden. If they don't give us the specific heat, we might have to look up the specific heat for wood. But right now we're going to assume that they're going to give it to us. It has a mass of 20 kilograms. So I go over here to the right part of my paper and I write M for mass equals 20 kilograms, okay? And a specific heat, they gave it to us, of 1,700 joules divided by kilogram degrees Celsius. So the symbol for specific heat is a C. So I do 1,700 joules divided by kilograms times Celsius degrees. There's actually a difference. If you measure a temperature and it's 10 degrees Celsius, you write it like that. If it's a temperature difference, like my temperature is changing in this one, and I'm finding, like if you want to say it heated up 10 degrees, and you're telling the difference, not the measured temperature, you're supposed to write it 10 Celsius and then the degrees on the other side. Now, there was a book I taught of that was real good about always doing this. Other books, they don't seem to know about that. But sometimes you'll see it, and that's why it's on the other side. It's because it's a temperature difference as opposed to a temperature. Okay, so now we've got the specific heat, and then it says, find the change in thermal energy. So my question mark is heat. Find the change in thermal energy of the block as it warms from 15 degrees Celsius to 25 degrees Celsius. So my change in temperature, remember this Greek letter delta means change or difference. The change in temperature is it goes from 15 to 25, but we do it this way because we want the absolute value, and that's 10 Celsius degrees. It looks like 100, but it's 10 Celsius degrees. So over here, the first thing you do is you list all your knowns and unknowns. Okay, so we got rid of all those words and we got it to nice numbers instead. Okay, the next thing is we say, is there a formula that relates MC and delta T? Why, yes, there is. So then you go over here and you write your formula. Write your formula every single time, because if you it will help you memorize your formula. Okay, next what we do is we sing a song, and the song is Substitute. It's by The Who. It's from before my time and yours, but it's to remind us that now right underneath the letter, we substitute the value. So mass is 20, specific heat is 1,700, and change in temperature is 10. And then we do the math. We multiply them together, and I already did it, but we'll do it again. So we get out our calculator, we turn it on, and I recommend you get one of these TI-84s, but other calculators will do this. Okay, this is my regular math screen. I'm going to hit clear and clear it out so you can see exactly what we're doing. And I do 20 times 1,700 times 10 equals, there it is, done, 340,000. 340,000. Now, what about the units? The units for heat are joules, and I want to show you The unit for mass was kilogram. The unit for specific heat is joules divided by kilograms times Celsius degrees. And the unit of temperature is Celsius degrees. If you have the same thing in the numerator and denominator, you get to mark it out. It's one of my favorite part of math. I like marking things out. This kilogram is in numerator land. That kilogram, because it's after the slash, is in denominator land, so I get to mark them out. This Celsius is in numerator land because it's after the slash. This Celsius degrees is in denominator land, so I get to mark them out. And what's left? Joules. So the unit is joules. Using the units to make sure you're doing the math right is a physics idea called dimensional analysis, and it can really help you. I had a girl once that I tutored, and she was in a magnet school, and she was taking physics, and she was not doing good, and she needed an A. And so she hired me to tutor her, and I showed her this one thing, and that's all she needed. After that, all A's. All she needed was a little help to understand that you can use dimensional analysis to find out if you're doing your math right or not. All right, so that's the problem. Do some practice problems. Make sure you got it. This is one area of physics that also overlaps chemistry. So we do these problems in chemistry also. But they're not hard. They're pretty fun. So science is great. See you later.